David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, remember that you can adjust the playback speed as you desire. Second, you can pause the video at any point to jot down notes or write down questions. Third, you can turn on the captions so you can read my words on the screen. Today's topic, indefinite integration, and then we're also going to cover a few integration rules that will help you do some of the more complicated problems. So let's get started. So first off, indefinite integration is kind of exactly what it sounds. It's indefinite, meaning you can't tell for sure. So let's take a look at this. We did address this briefly in our last lesson, so we're going to just get a little bit more all over it today. So here's an integral that we've done. The integral of 2x dx ends up being x squared. That's just using this power rule, which you've seen before. We're going to go over again today. But basically, 2x dx becomes x squared. But now we have this plus c, and that stands for some constant that's out there. We don't know what that constant is. So that's why it's called indefinite integration. We just know that when we take the integral of 2x, we get x squared plus c. Now, why? Why do we have to throw that constant out there that we don't know? It doesn't seem very solid. It doesn't seem very, very mathematical. Well, the explanation is actually kind of simple. Remember, integration is the opposite of derivation. So just like multiplication and division are inverse operations, so is integration and derivation. So let's take a look at 2 derivatives. The derivative of the function x squared plus 2 ends up being 2x. Because in the last video, I showed you how when you take the derivative of a constant, it becomes 0. So the 2 just goes away, and we have x squared going to 2x. But check this one out. X squared minus 7, same derivative. It's going to end up with 2x. So here's the thing. If derivation is going that way, integration is going this way. So if you're taking an integral of 2x, these are both possible outcomes. In fact, you can see from this that there's an infinitely many number of possible outcomes. So we don't know whether it's plus 2 or minus 7 or minus 60 pi or whatever else it could be. So we just have to say, when we integrate 2x, we get x squared plus c, this indefinite constant. So that's indefinite integration. So if you're doing your math correctly and doing all your record keeping, whenever you take an integral, you're going to remember that there is a plus c out there. Okay, let's take a look at 3 rules for integration. The first one you know. This is called the power rule. And this is when you have x to the n dx. You just do this trick here. You do 1 over n plus 1 times x raised to the n plus 1. And then you don't forget your constant goes out there. So we've been doing this rule already. You've seen it in our last unit as well. So this is basically the integration power rule. Okay. The constant rule. We also talked about the integration of a constant in our last episode. That's good. The last lesson. So some constant k. So for taking the integral of k dx, you're going to end up with kx. That's what happens when you take a constant and you integrate. You end up with that constant times x. And then again, we have our indefinite component, our constant here, plus c. So this is the constant rule. Finally, we have some difference. This is kind of 2 rules. It's for adding integrals up or subtracting them. So here's my notation. It's a little bit parenthesis heavy, but it's all there. So if I'm taking the integral of big parentheses around 2 functions, f of x and g of x, either added or subtracted. So this is the integral of 2 functions, added or subtracted, dx. We can break that up and integrate the first function and add or subtract it to the integral of the second function. So this makes sense. In fact, we did an example in the last lesson that did one of these types of problems. So let's go ahead and do some problems. Okay, let's do a more complicated example. Here's one for you. Take the integral of 3x to the 4th plus 6x squared plus 2 dx. So the first thing I'm going to do is I'm going to use this rule here to break this up into a more easy to attack problem. So this is just going to be the integral of 3x to the 4th dx plus the integral of 6x squared dx plus the integral of 2 dx. So now I can attack each one of these separately. So let's just move along here. So now I can use my power rule to evaluate each of these individual integrals. So the first one, 3x to the 4. I'm going to end up with 3 over my power plus 1 times my x to my power plus 1. And then I'm going to get plus 6 over my power plus 1. That would be a 2 plus 1 to the x to the 2 plus 1. And then here's my constant rule. That's just going to end up giving me, when I have a constant, it's just kx. So now I got my 2, so that's just 2x. And then don't forget your plus c out there. Now, each of these two is going to have its own plus c if it were separate, but we can combine those c's because we know if this is whatever they would be, they could be added or subtracted together because they are constants. So we just have to have one c out there. So let's finish this up. This is going to be 3/5 x to the 5th plus 6 over 3 is going to be 2x to the 3rd plus 2x plus c. And then let's just fix our fraction here and do 3x to the 5th over 5 plus 2x to the 3rd plus 2x plus c. Okay, let's try another one. Here's the integral of x plus the 3rd root of x dx. So first off, I have two functions inside, so let's break them up. This is going to be the integral of x dx plus the integral of the 3rd root of x dx. So now let's make this a little bit, let's just work the problem. Okay, so x dx, we're going to have 1 over 1 plus 1 x to the 1 plus 1. Because this is x to the first power, okay, so I'm just using my power rule here to get this term having been integrated. Now, the 3rd root of x, if you remember from the last lesson, the 3rd root is the same as the 1/3 power. Okay, so I'm going to rewrite that there. Let's move it right along. This is going to be 1/2 x to the 2, 1/2 x squared. Now this one is going to be 1 over 1 plus 1/3 x to the 1 plus 1/3. So get ready to deal with your fractions. I'm going to put this as x squared over 2. That's our first term, just simplifying that a little bit. Plus, there's a plus here. This is going to be 1 over 4/3 x to the 4/3 power. And this is where it's going to get a little tricky simplifying your exponents. So if you recall those rules I put up on the right side of your screen in our last episode, those are the rules you need to evaluate this. So let's carry this forward. X squared over 2, that's that term, stays the same. Okay, so 1 over 4/3 is the same as 1 times 3/4. So this is going to become 3/4 x, and 4/3, actually let's just leave that there and do one more step. Bring my x squared over 2 over here. Now I have, on the top, I have a 3. Now x to the 4/3 is the same as the 3rd root of x to the 4th, and this would be over 4. So there you go. That's the answer to that problem. Okay, let's do another one. Here it is. Put my dx out there. Integral of 3x to the 5th minus 2x squared plus x dx. So let's break that up. We're going to use this rule here to break it up into 3 integrals. This will be the integral of 3x to the 5th dx minus the integral of 2x squared dx plus the integral of x dx. Kind of running out of room there a little bit. Okay, so now let's work these problems. So these are all going to be straightforward applications of our power rule. So the first one is going to be 3 over 5 plus 1 x to the 5 plus 1. Now we have a minus 2 over 2 plus 1 x to the 2 plus 1. And finally plus x, or not plus 1 over x, 1 over 1 plus 1, x to the 1 plus 1. So I'm just using this power rule over and over and over again. It should become pretty second nature to you by the time you're done, say, with tonight's exercises. Okay, so let's simplify this out. This is going to be 3 over 6, so this is going to give me x over 2, 1/2 x to the 6th, right there, minus 2/3 x to the 3rd, like that, and then finally 1/2 x squared. Or let's write that as, I like it like this, x squared over 2. Okay, so that's our integral. Okay, I've got one for you to try. So pause the video, see if you can do that one. A little tougher, a little more complicated. Now that you've watched the video, take a moment to jot down additional notes, some questions for class, or a short summary of the lesson. You can also go back and re-watch the portions of the video that were a little bit challenging for you. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.